Hi friends, today we're going to talk about our quiz from Friday over functions. I'm going to start with number one. Number one says write a function rule for the output is 5 less than the input. So I'm going to take this step by step. The first thing I know is that the output is our letter Y. So I'm going to start with Y. And then is always means I'm going to put my equal sign. It says 5 less than the input. So if it's less than the input, I know I'm going to be subtracting, and I know my input is letter X. And if it's 5 less than X, that's the same as saying X minus 5. Our independent variable is our letter X, and our dependent variable is our letter Y. Y depends on what X's value is. For number two, it says find the value of Y for the given value of X. I'm going to take this number one and I'm literally going to replace it with X. So now instead of X, I'm replacing X with 1. So when I rewrite this, it is going to look like Y equals -4, and I'm multiplying it by 1, which is what those parentheses indicate, and then plus 6. -4 times 1 is -4. Plus 6, and I know that -4 plus 6 is 2. So for number 2, Y equals 2. For number 3, we have to be careful with number 3 because this time we're switching it. Instead of finding the value of X or finding the value for Y, yes. Or I'm sorry, I said that wrong. Instead of finding the value for Y, we're finding the value for X. So instead of putting this -18 in for X, we're going to actually plug it in for our output of Y. So this is going to be -18 equals 1/2 X. Remember with fractions, in order to get X by itself here, I have to multiply by the reciprocal. And the reciprocal is just the flipped version. So instead of 1/2, I'm going to multiply both sides by 2. And when I do that, the 2's cancel. I'm left with a singular X. And then -18 times +2 is -36. Flipping it over to the next side, for number 4, it says determine whether the relation is a function and explain. So we're going to write yes or no, and then just a brief description as to whether it is a function or not and why. So I know that this table is a function. Yes, because all input values have exactly one output value. Which is just saying that all of my input values are different. I don't repeat any X values. Looking at number 5, my set of ordered pairs here, I notice that 2 of my X values are the same, and that can't be. We cannot have 2 of the same X values with ordered pairs. So this is not a function, no, because 2 X values repeat. Flipping it over again to number 6. Number 6 says determine whether the relation is a function. Explain. So for this graph, I can't show this to you because I don't have a video, but I always tell my students to do the vertical line test. So you just would put your pencil on the graph and drag it across. And if there are no 2 points on the same vertical line, right, like this is a vertical line, if there are no 2 points on the same vertical line, then it is a function. And I see here on this graph that is the case. So this is a yes, this is a function. There are no 2 points on the same vertical line. And then moving down to number 7, once again, we're looking at a graph and we're trying to decide whether it is a function or not. I see here I have 2 points on the same vertical line, multiple times actually. So this is not a function, no. There are 2, I cannot write as fast as I talk. There are 2 points on the same vertical line. Okay, flipping it over again. Last page, number 8, says graph the ordered pairs on a coordinate plane given the input-output table. Okay, so I'm going to use the table to graph these points. Now, for me, I'm going to put these into ordered pairs for you just to make it easier. You don't have to do it. I'm just doing it so that you can see how to plot. So I can make each of these values in the table into ordered pairs. Remember, the x comes before y, and the easiest way for me to remember that is that in the alphabet, x also comes before y. And when I plot these points, I'm going left to right first, my x values first, so left to right and then up or down. So I'm going to make this a little bit bigger. 8, 1, I'm going to go to the right 8 and up 1. And then for 7, 2, I'm going to go to the right 7 and up 2. For the next one, I'm going to go to the right 5, up 2. For the next one, I'm going to the right 3 and up 3. And for the last one, I'm going to the right 1 and I'm going up, oops, that was an accident. Going right 1 and up 1, 2, 3, 4. So there you have it. Those are your points you should have plotted for number 8. And the last question here is just a review of what we've been doing last week, solving inequalities. So I'm going to start out by distributing this -3. Remember, when I distribute, that means that I multiply. So I'm going to take, and I'm just going to bring down my 30, my inequality sign greater than or equal to, and I'm distributing the -3, which means I'm multiplying both parts inside the parentheses. -3 times 5 is -15, and -3 times 5x is minus 15x. And remember that when I multiply a negative and a positive, my answer is going to be negative. Now I want to get this x by itself, but in order to do that, I have to get my like terms together. So I'm going to add these numbers here. 30 plus 15 is 45. Bring down my inequality sign, and now I'm left with -15x. Now that I've combined my like terms, I'm going to divide, right, because the opposite of multiplication is division, and that -15 and x are being multiplied. So when I divide both sides by -15, the -15's cancel, I'm left with an x. Remember, with inequalities, if I divide by a negative, I have to flip my sign. So now instead of less than or equal to, it's going to be x is greater than or equal to. And then 45 divided by -15 is -3. So x is greater than or equal to -3. Good job, friends.